Hello viewers and students, you are welcome again to this channel where we are considering various topics in chemistry such as stoichiometry. In the previous video, I've explained the first part of stoichiometry using mass to mass relationship. We have considered some examples of stoichiometric questions and how to solve them using mass to mass relationship. Kindly subscribe to this channel so that you can have access to more updates. Share and like, and don't forget, always turn on your notification bell so that anytime there are new updates, you can easily have access to them. Subscribe to this channel. Today we are looking at another part of stoichiometric calculation using mass to mole relationship. We shall consider some examples as follows. Example 1. Calcium triazocarbonate 4 reacts with triazonitrate 5 acid according to the equation below. The equation of the reaction is given. If 20 grams of the triazocarbonate 4 reacted completely with the acid, calculate the amount in mole of the acid that reacted. In this reaction, we are relating two substances together. Don't forget, in the previous video, I explained that whenever you are solving stoichiometric questions, the first thing that you need to consider are the substances we are relating together. Consider and identify the substances that are related together in the question. Like in this example, the substances we are concerned about are calcium triazocarbonate 4 and triazonitrate 5 acid, whereby we want to determine the amount in mole of the acid that reacted completely with 20 grams of the triazocarbonate 4. And this is a question that involves relating mass of triazocarbonate 4 in grams reacting with mole of the acid. So we are using mass to mole relationship. Mass to mole relationship. So let's look at how we are going to solve this question using mass to mole relationship. The first thing we are going to do is to calculate the molar mass of the triazocarbonate 4. Anytime you are given the mass in gram of a substance in a question like this, you will always need the molar mass to solve the question. So we are going to calculate the molar mass of the triazocarbonate 4, the calcium triazocarbonate 4, by using the atomic masses given in the question. So let's calculate the molar mass. That's the first thing we do. Molar mass of calcium triazocarbonate 4. You multiply the number of atoms by the atomic mass of each element given as follows. 3 times 16, 40 plus 12 plus 48, and that gives us 100 grams per mole. That's the first thing that you do. Calculate the molar mass. Don't forget, we are using mass to mole relationship. We want to calculate the amount of the acid in mole that 20 grams of the triazocarbonate 4 would completely react with. So the first thing that you have to do is to calculate the molar mass of calcium triazocarbonate 4. Then we move to step 2. That is where we now use the mass to mole relationship using the mass to mole relationship. Using mass to mole relationship. We are relating the mass of the triazocarbonate 4 with the amount in mole of the acid. So we are going to look at the equation. Always start from the mole to mole relationship. In the equation of the reaction given, we have 1 mole of the calcium triazocarbonate 4 CaCO3 reacting with 2 moles of the acid HNO3. So relating them mole to mole, we have 1 mole of CaCO3 reacting with 2 moles of the acid HNO3. You start from there. Then what we do, we change the mole of the CaCO3 to mass in gram. And don't forget, in the previous video, I've explained that when you are converting the mole of a substance to the mass in gram, what you need to do is to multiply the mole by the molar mass given or that you've calculated. In step 1, we have calculated the molar mass of the CaCO3. So we are going to multiply the molar mass by the 1 mole given in the reaction to get the mass in gram as follows. 1 mole multiplied by the molar mass 100 gram per mole of CaCO3 reacting with 2 moles of the HNO3. So you see the mole we cancel mole, so we have 1 into 100 grams of CaCO3 reacting with 2 moles of HNO3. Therefore, we have 100 grams. The 1 mole of the CaCO3 is now equivalent to 100 grams. Don't forget, what we are using to solve this question is mass to mole relationship. We are using the mass of the calcium triazocarbonate 4, 20 grams, to determine the amount in mole of the acid that reacted. So let's go on. 100 grams of CaCO3 reacts with 2 moles of HNO3. By proportion, we have 1 gram of CaCO3 will react with 2 over 100 in mole of HNO3. Therefore, you now go to the mass of the calcium triazocarbonate 4 put into reaction, which is 20 grams. So if 1 gram of calcium triazocarbonate 4 will react with 2 over 100 mole of HNO3 proportionally, then we have 20 grams of the CaCO3 will react with 2 over 100 multiplied by 20 all in mole of HNO3, and that will give us 0.4 mole of the acid HNO3. So that's how to solve that. So that is, in the reaction, 20 grams of calcium triazocarbonate 4 will react with 0.40 mole of the acid HNO3. That's how to solve that, by using mass to mole relationship. using mass to mole relation. So you have been able to calculate the amount of the acid that the 20 grams of the triazocarbonate 4 will completely react with. Look at the steps. We started by calculating the molar mass of the calcium triazocarbonate 4 so that we can use that in step 2. In step 2, we started from the equation by relating them mole to mole. 1 mole of the CaCO3 reacts with 2 moles of the HNO3. And we converted the 1 mole of the CaCO3 to the mass in gram by multiplying the 1 mole by 100 gram per mole, the molar mass. So the 1 mole is now equivalent to 100 gram of that CaCO3 reacting with 2 mole of HNO3. So the HNO3 is in mole, while the CaCO3 is now in gram. So by proportion, 1 gram of the CaCO3 will react with 2 over 100 mole of HNO3, and 20 gram, which is the actual mass of the CaCO3 that reacted in the reaction, will react with 0.40 mole of HNO3. That is how we solve the question using mass to mole relationship. Let's go to example 2. Calculate the amount of sulfur 4 oxide required to deposit 12.0 gram of sulfur on reacting with excess hydrogen sulfide according to the following equation below. Again, in this question, we are looking at the amount of sulfur 4 oxide that will be required to produce 12 grams of sulfur. So if you look at the question, we are relating mole and mass together. We want to determine the amounts of SO2 in mole that will be required to produce 12 grams of sulfur in the reaction, mass to mole relationship. Again, start from the mole to mole ratio of the two substances. The two substances that we are concerned about are sulfur 4 oxide and sulfur, SO2 and sulfur. So those are the two we are relating together, starting from the equation. From the equation, we have 3 moles of sulfur. We start from that. 3 moles of sulfur produce 3 moles of sulfur produced by 1 mole of SO2 according to the equation of the reaction. We have 3 moles of sulfur being produced by 1 mole of sulfur 4 oxide, SO2, in that reaction. So we calculate the molar mass of that sulfur, because we are given 12 grams in that question. So we need the molar mass of that sulfur so that we can convert the mole, the 3 mole, to the equivalent mass in gram. So let's calculate the molar mass. The molar mass of sulfur. The molar mass of sulfur, being an element, is going to be 1 multiplied by 32 gram per mole, and that is 32 gram per mole. That's the first step. The next thing that you do is to relate the two of them, mass to mole, with each other. Don't forget, in the equation you have 3 moles of sulfur produced by 1 mole of SO2. So we change using mass to mole relationship, mass to mole relationship. So you have 3 mole, the 3 mole multiplied by 32 grams per mole. You always multiply the mole by the molar mass of the substance to get the mass in gram. So of sulfur produced by 1 mole of SO2. The mole will cancel each other to give us 3 into 32 grams of sulfur produced by 1 mole of SO2, and that will give us 96 grams. When you multiply both, you have 96 grams produced by 1 mole of SO2. So that is according to the equation. The 3 moles of sulfur is what is equivalent to the 96 grams. Don't forget, we converted the mole. When you are converting mole to mass, you multiply both the mole and the molar mass of that substance together, and that is how you get the mass. So the 3 moles of sulfur is converted to 96 grams in mass. So sulfur is now in grams, and the 1 mole of SO2 is still intact. So if 96 grams of sulfur, which is the 3 mole of the sulfur according to the equation, would be produced by 1 mole of sulfur oxide SO2, 1 gram, then 1 gram of the sulfur will be produced by 1/96 in mole, 1/96 of SO2, and finally the 12 gram, which is the mass of the sulfur, the actual mass of sulfur reacting, will be produced by 1/96 multiplied by 12 in mole of SO2, and when you divide, that will give us 1/8, which is equals to 0.125 mole of SO2, and that is how to calculate that, how to solve that. Don't forget, we were using mass to mole relationship. We are calculating the amount of sulfur oxide that will be required to produce 12 grams of sulfur, which is the mass. So I started from the equation by relating both sulfur and the SO2 mole to mole to each other, and that is 3 moles of sulfur produced by 1 mole of SO2 from the equation. The next thing is change the mole of sulfur to mass, to molar mass. You calculate the molar mass of that sulfur, and that is 32 grams per mole. Then the next thing is to change the 3 mole of the sulfur to the mass in gram by multiplying 3 mole and 32 grams per mole together, and that gives us 96 grams. That's the equivalent mass in gram of the 3 moles of that sulfur. So the 96 grams of sulfur is produced by 1 mole of sulfur oxide, and by proportion 12 grams of that sulfur which was put into reaction will be produced by 0.125 mole of sulfur oxide. We have used mass to mole relationship to solve this. So that is how to go about stoichiometric calculation using mass to mole relationship. Kindly subscribe to this channel to have access to more updates, and don't forget, turn on your notification button so that you can always receive the update whenever is released into this channel, and subscribe. Refer to the previous videos where I've treated stoichiometric calculations using mass to mass relationship. Today we consider stoichiometric calculation using mass to mole relationship. Don't forget to subscribe, share and like. Drop your comments in the comment section and wait for the next video soon. And you can also try this self-assessment question. Try this self-assessment question while watching the video. You can pause to solve this question on your own. And if you have any issue that is not clear, you can always contact me on my WhatsApp number or my email address. See you in the next video. Thank you.